Hello, good evening, Joshita, good evening. Still anyone is in live? Good evening, Akshara, good evening. Good evening, Bindu Velanki. Good evening, Guru Sai Charan. Good evening, Janakiram. Good evening, Tanvi. Good evening, Ranit. Good evening, Subhana. May I know who is this Kalavati? May I know who is this Kalavati? Kalavati. Still any other? Good evening, Sai Vaishnavi. Good evening, Suraj. Okay, okay. Good evening, Kirtana. Right, 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 right. Good evening, Amit Dubey. Good evening. Good evening, Ajit. Good evening, Yashwant. Right. Now, my dear friends, now this is your kind information for you that you know, right? Maximum to maximum for the each question, try to take the 1 minute and 1 minute 15 seconds max to max I will give you. Okay? Then if you don't know the answer, just give me the question mark. And the questions are not that much lengthy. See the each and every option. Don't be in hurry to say the answer. Cross check the units. Okay? Cross check the units and read the question carefully. Right? Here we are not hurry. Like I should only say the first and all. Right, my dear friends, each and every option cross check and say me the answer, because these three chapters are like a tricky. Now, atomic structure, we know the calculation, classification of periodic table, already we know many of the tricky questions, and chemical bonding, we know the already we know I was given you the trick. The trick is helpful for you to identify the which one hybridization and the number of lone pair, but molecular geometry you have to cross check. Good evening, Venkata Sai Kirtan, good evening, Srinitya, Bhakti, something wow, she is saying. Now, Jagadish, hi, Jagadish, right now I'm going to start the questions. Bhakti, may I know who is your name? Now, right. Now we'll go with the first question. Now, which one of the following is an isobar of nitrogen 14? Hi, Akil. Hi. What is the answer? What is the answer for this question? What is the answer for this question? Okay, Dinesh. Okay. Okay, good evening, Dinesh. Now, what is the answer for this question? What is the answer for this question? Which one of the following is an isobar of? Now, what is the meaning of the isobar, Nana? What is the meaning of isobar? What is the definition of the isobar? Good, Ashwan, good. Answer is 3. Isobar means different atomic number, same mass number, it should be there, right? Answer is 3. Answer is 3. Yes, yes, yes. Answer is 3. Isobar means same mass number but different atomic number. Right? Now I will write you somewhat some compounds here. Yes, good one. Good. Now I will write some compounds. You have to say me the answer. No. 7 and 17, F and 9. Now, in these three compounds, good evening Vishal, good evening. Now, in these three compounds, may I know how many neutrons are there in all the three? May I know what is the neutrons that are present in this one? In the first one, how many neutrons? Second one, how many neutrons? Third one, how many neutrons? May I know how many neutrons are present in the first one? How many neutrons are present in the second one? How many neutrons are present in the 8 neutrons in the first one? Neutrons, how to find out the neutrons? Atomic mass is equal to atomic number plus neutrons, right? Now neutrons, if you take it to the left hand side and the atomic mass to the right, atomic mass minus atomic number. Clear? In all the cases 8 and 8. Right. 8. Good. Everyone good. Right. Now we'll move with the second question. Right. Good. Everyone good. Now, covalency of the nitrogen in ammonium ion. My dear friends, he is asking in ammonium ion. In the ammonium ion, what is the covalency of the nitrogen? My dear Samir, now my dear friend Samir, don't be nervous. Now you can work hard. Sure, you will get the success. Right. Now what is the answer? Now answer is 2. Someone, Tanvi is saying 2. Now Bindu Mohan is saying, no. 3. Everyone is saying 3. My dear friends, once again, ammonium ion, you don't know the ammonium ion? No. He is asking ammonium ion. Abhishek has said 4. Option number 3. Actually, the covalency of the ammonium ion means this is nitrogen, this is hydrogen. Clear? Now, this lone pair of electron will be given to the electron deficient species in the form of the coordinate covalent bond. Now, already I explained you very clearly. Ammonium ion. This is the ammonium ion. NH4 plus is the ammonium ion. Nitrogen maximum covalency is the 4. I explained very clearly about this one. Maximum to maximum, nitrogen can form only the 4 bonds. Right? Nitrogen covalency is 4, not 3. My dear friend, this is very important. Once again, I was explaining very clearly. Now try to believe that nitrogen covalency is 4, not 3. We know that nitrogen to complete its octet, it requires 3 electrons. Clear? Now also it has completed its octet. Now we know, right? Coordinate covalent bond means this lone pair of electron is between this hydrogen as well as the nitrogen. It is between both the cases, both the nitrogen and hydrogen. So covalency of the nitrogen is 4, not the 3. So the option number 3 is correct. Is it clear, everyone? Right? Covalency of the central atom is maximum. He is asking now among the 4 given compounds. Now the covalency for central atom is maximum in nothing but covalency for central atom is maximum in is nothing but in which case which one has formed the maximum covalent bonds, he is asking indirectly. Indirectly is asking in which case maximum number of covalent bonds are formed. In which case the maximum number of covalent bonds are formed, indirectly is asking. Ketan is saying 4. Maximum number of the covalency for the central atom is maximum in. Ajit Boxer is saying 3. Abhishek is saying 2. Yashwant is saying 3. My dear friends, cross check the each and every option. Don't say it blindly. Don't say it blindly. Cross check the each and every option. Akhil is saying 1. Vishal Raj is saying 3. My dear friend, once you cross check the each and every option, once again you cross check the each and every option. My dear friend, the maximum covalency we are going to see in the SO2Cl2. How the sulfur valency electrons are, how many? Sulfur valency electrons are 6, right? Sulfur valency electrons are 6. Now, here each oxygen will form the what? Double bond. Now, each oxygen will form the double bond. Now, each chlorine will form the single bond. Now, you can see maximum number of the covalent bonds 1, 2, 3, 4, 5, 6. Now, in the case of POCl3, phosphorus maximum to maximum valency is 5. Maximum valency for the phosphorus is 5. Now, oxygen will form the double bond. Here it is a Cl. Here it is a Cl. Here it is a Cl. In the POCl3, maximum covalent bonds are only 5. Here the maximum covalent bonds are 6. In the BeCl2, if you cross check, in the BeCl2 only 2 covalent bonds. 2 covalent bonds. In the BF3 only 3 covalent bonds. Covalency is nothing but maximum number of covalent bonds formed. Maximum number of covalent bonds formed is known as a which one? Is nothing but covalency, right? Is it clear, everyone? Answer is 2. I hope it is clear. Is it clear? My dear friend, the answer is 2. Is it clear? Okay, right. Next one. Now, the molecule that deviates from octet rule. The molecule that deviates from the octet rule. The molecule that deviates from the octet rule. The molecule that deviates from the octet rule is. What is the answer? Hi. Central atom is large size only, right? Compared to the Here the oxygen, sulfur. Here the fluorine, chlorine. Down the group size increases. Now left to right size also increases, right? Left to right size also increases, right? My dear friend, size increases. Now what is the answer you got for this one? Now what is the answer for this question? BeCl2. Yes, answer is BeCl2. Here BeCl2 has been deviate from the octet rule. Deviate from the octet rule. Now NaCl, Na plus and the Cl minus octet, Mg plus 2, O minus 2 octet, N clear. Now the nitrogen N minus 3 nitrogen, it has formed the octet rule with the 8 electrons. So the answer is only BeCl2. Next one. Expanded octet can be observed in the valency electrons of central atom in. Is asking expanded octet. Expanded octet is nothing but hypervalent. Hypervalent octet can be observed in the valency shell of the central atom in. Central atom in. Just to cross check the expanded octet. Expanded octet, you just cross check. My dear friends, you just cross check the expanded octet. Akhil is saying 3. PCl3, everyone, PCl3. There is no any option PCl3. Yes, PCl5. PCl5 is a yes, PCl5. PCl5, not the PCl3. It is PCl5. Now, NH3 nitrogen contain 5 valency. Each hydrogen will form the single bond. Now its octet completed 8 electrons. CH4, each carbon contain 4 electrons. Each hydrogen, and here it is a 8 electrons. Now BeCl2, this is less than octet. Less than octet, right? BeCl2 is a less than octet. Right, now the PCl5, it is expanded octet. How? Now total 5 bonds it is forming. Total 5 bonds it is forming. So the central atom it is having the 10 electrons. So expanded octet. The answer is 3. Okay, done. Now next. The molecule which contain only bond pair of electrons on the central atom. Now, my dear friends, don't be in hurry to give the answer. Each and every question you cross check and give me the answer. Molecule which contains only bonded pair of electrons on the central atom is. What is the answer? Molecule which contains only bonded pair of electrons on the central atom is. Akhil is saying 3. Abhishek is saying 2. Kirtan Joshita is saying 3. Kirtan saying 1. Subhana is saying 3. Ashok Dev is saying 3. Abhishek is saying 3. Tanvi is saying 3. Amit Dubey is saying 1. 3, 3, 3. Yes. Sharon is saying 3. Yes, yes, yes. Now, the molecule which contain only the bonded pair of electrons on the central atom is only 3. Now, nothing but here you know right, H2O. H2O we know it is sp3 with 2 lone pair. sp3 with a 2 lone pair. How the H2O will be there? Now, 2 bond pair of electron and 2 lone pair of electron on the central atom, right? H2O. Now, if you cross check the NH3, 3 bond pairs and 1 lone pair, and the BRF3 also if you cross check, BRF3 we are having the 3 fluorines and 2 lone pair of electrons, but he is asking only the bonded pair electrons. Means bonded pair electrons means nothing but indirectly is asking in which case lone pair of electrons are absent on the central atom. So BeCl2 only the bonded pair of electrons are there, but there is no any lone pairs on the central atom. The answer is only 3. Clear? Is it clear? Done? Still you are having any confusion? Is it clear, my dear friends? Next. Lattice energy of an ionic compound depends upon. Lattice energy of ionic compound depends upon. Next. Lattice energy of an ionic compound depends upon. Okay, good. Lattice energy of ionic compound. Acha. Okay, Prasanna. Okay, fine. Okay. Raj, Ajit, Karthik, Yashwant, Joshita, Subhana, Sai Kirtan Sai. Everyone is saying 1. Right. Lattice energy. Now we know right. Lattice energy is nothing but lattice energy is directly proportional to the charge of cation and charge of anion, and inversely proportional to the radius of cation and the radius of anion. Means lattice energy is directly proportional to the depends upon the charge on the ion as well as the size of ion. Clear? Charge of the ion as well as the size of the ion. Right. Means lattice energy is directly proportional to the charge of the cation. Means charge of the cation is high, lattice energy is high. Now if the charge of the anion is high, lattice energy is high. Now if the radius of the cation is less, lattice energy is high. If the radius of the anion is less, now lattice energy is high. Right. Yes. Sri Ganesh. Okay. I know. Sri Ganesh, I know. Least ionic compound among the following is. Least ionic compound. My dear friends, I think so. This is based on the least ionic compound is asking. My dear friends, if you know, try to say me. Actually, this is on the basis of Fazan's rule. Unfortunately, I was kept this question. This topic was not completed. Least ionic compound among the following is asking. Actually, the answer is 4. This is on the basis of Fazan's rule. My dear friends, if you know the answer, try to say. If not, leave it. Actually, this question's answer is 4. This is on the basis of Fazan's rule. Now, what does it mean? Least least, I mean, small size cation, small size cation, small size cation, and large size anion, and large size anion. Small size cation and the large size anion will form least ionic compound. Least ionic compound. This is a one point you have to remember for the least ionic compound. Actually, small size cation and the large size anion will get only in the fourth. Only in the fourth option will get. Right? Right. Now we'll move to the next question. Now the compound which is having the high lattice energy. Compound which is having the high lattice energy. The compound which is having the high lattice energy. Can anyone say me the compound which is having the high lattice energy? Compound which is having the high lattice energy. Compound which is having the high lattice energy. Answer is 3. Any other? The compound with the highest lattice energy. The compound with highest lattice energy is okay. Everyone is saying answer is 3. No, lattice energy means only you have to cross check charge of cation and charge of anion and radius of cation and the radius of anion. If the charges are same, then you go for the radius. Now, if we know, right, it will be dissociated as a K plus Br minus. Here it will be the Li plus and Br minus. Now here it is a Na plus and Br minus. Here it is a Rb plus and Br minus. Now in all the cases Br minus is same. Now we know, right, Li plus, Na plus, K plus, Rb plus. Top to bottom size increases. Top to bottom size increases. Now you see, lithium, it is having the small size. Lattice energy is inversely proportional to the radius of cation. Now small size cation, high lattice energy. Clear? Now LiBr is having the high lattice energy. So the answer is 3. Hello Sonu. Hello. The answer is 3. Right? Now the shape of hydronium ion is. The shape of hydronium ion is. Already I did, my dear JEE wala. Already I did in my channel. Already the live question session was done on the structure of atom. Now the live question session was done on the classification of periodic table. Now I was combiningly structure of atom, classification of periodic table, chemical bonding. 3 chapters combiningly I brought the questions and I was doing the live. Now this is of the 3. Once again explain. What I have to explain once again? Here top to bottom size increases. Top to bottom size increases means what I said. If the size increases means lattice energy decreases. Now less size, high lattice energy. Li plus is having the least size. So the answer is 3. That's it. Now what is the shape of hydronium ion? What is the shape of the hydronium ion? What is the shape of the hydronium ion? Shape of the hydronium ion is pyramidal, right? Hydronium ion will be in this manner. H3O plus H3O plus is the hydronium ion. Now oxygen is the central atom. We know, right? Oxygen contain 6 valency electrons, right? Now this plus indicates that one electron has been lost, and we are having the 3 hydrogens, 1, 2 and 3. Now this represents S, this represents P, this represents P, and this represents a lone pair, and this is P. Now this we call it as a sp3 with one lone pair, right? sp3 with one lone pair. sp3 with one lone pair is a pyramidal shape. sp3 with one lone pair. Tetrahedron means sp3 with 0 lone pair. Now square planar means we know, right? sp3 d2 with 2 lone pair. sp3 d2 with 2 lone pair. Now trigonal planar means sp2 with 0 lone pair, right? Now which of the following species the only having the planar structure? Only planar structure. Planar nothing but square planar. Nothing but square planar structure. Out of the following species that one has having the planar structure is nothing but square planar indirectly. Which of the following is having the square planar structure? In which of the following the square planar structure it is a? Pavit Raj answer is saying 3. Joshita is saying 3. Prasanna saying 3. Yashwant saying 3. It is more than enough, my dear friend. My dear friend, if you are preparing for the JEE, it is more than enough. Karthik Chandana is saying 3. Now, what is the structure of first option? My dear friends, can anyone say what is the structure of first one? According to this question, answer is 3. How xenon contain 8 valency and each fluorine will form the single bond. Now this is a S, this is a P, this is a P, this is a P, and this is a D, and this is a D. We know, right? sp3 D2 with a 2 lone pair. sp3 D2 with a 2 lone pair. Okay, Sai Vaishnavi. Okay, ma Sai Vaishnavi. Fine. Now, hi Udit. Hi. Now the be focus to the class. Now, according to this one, now what is the structure of the first one? What is the structure of the first one? What is the structure of the first one? Now, we know, right? NH4 plus is sp3 with how many lone pair? 0 lone pair. Now, BF4 minus is sp3 with 0 lone pair. Now, this one is sp3 with 0 lone pair. All are tetrahedral structures. No. All are tetrahedrals, my dear friend. sp3 with 0 lone pair, sp3 with 0 lone pair, sp3 with 0 lone pair. Now this one only sp3d2 with 2 lone pair. Right? Now next one. Hybridization of N. Hybridization of the N in each of the following. Right, good. Okay, my dear friend, one by one, next atomic structure and periodic table questions will come. Now this, it may be new for you. Now if you know the concept, try to give the answer, Udit. If not, now the next atomic structure and the classification of periodic table questions will come. Okay, then you can try and give to the answer. Now say me the answer for this one. Nitrogen N, NO2 plus, NO3 minus, NH4 plus, hybridization. What is the answer? Answer is someone is saying 2, someone is saying 1. Yes, NO2 plus, right? NO2 plus. Nitrogen contains 5 valency, but plus indicates that 1 electron lost, and oxygen will form the double bond. So this is Sp, this is S, and this is P. Now next one, NO2 plus. Next one is NO3 minus. Nitrogen total 6 valency. Now if you cross check, now this is a S, P, and this is P. So NO2, NO3 minus is a Sp2. Now NH4, if you cross check, NH4 plus is a Sp3. So the option number 2 is correct. Sp, Sp2, Sp3. Sp, Sp2, Sp3 is the correct one. Is it clear? Yes, yes. Oh, fine. Next one. Now hybridization of central atom in OSF4 and OXF4. Now hybridization in the central atom in OSF4 and OXF4. My dear friend, see the question carefully and try to give me the answer. What is the answer? I think so. This is new molecule for you. OSF4 and OXF4. Janakiram is saying 1. Janakiram is saying 1. Sai Vaishnavi is saying 1. It is completed. Now, Udit, just 3-4 questions are left for the, only 3 questions are left for the, which one? Chemical bonding, and the next questions are of classification of periodic table, then followed by the atomic structure. Answer is 1. Yes. Now we know, right, oxygen, fluorine and the sulfur. Sulfur is a central atom. Sulfur maximum to the maximum, it will form the 6 bonds, right? Now this is a OSF4 structure. Now here the Sp3, how many bonds we are having? This is sulfur 1, 2, 3, 4, 5, 6. Now oxygen will form the double bond, and each fluorine. This is S, P, P, P and D, Sp3D. Now xenon 8 valency. Xenon contain 8 valency. Now here the oxygen, here the fluorine, here the fluorine, here the fluorine, here the fluorine. Total here is P, 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 and here it is a D, and here it is a D. One is Sp3D and one is a Sp3D2. One is Sp3D and one is a Sp3D2. Okay? Right. Answer is 1. Answer is 1. Among the oxygen, what I said, now when I was saying the Lewis dot structure, I explained very clearly, right? Central atom should be should be high in size. Central atom should be high in size. Then among the oxygen and the sulfur, we know, right? Here the oxygen, here the sulfur, and here the fluorine. Left to right size decreases, and top to bottom size increases. So among the oxygen and fluorine, sulfur is a more high, right, in the size. So that's the reason sulfur is a central atom. Any compound to behave as a central atom, it should be the less electronegative and as well as what? Less electronegative as well as it should be the high in size. What? No, answer is one, sp3d and sp3d2. Answer, right. Ah, now he is asking the formal charge on the oxygen atoms marked as per the diagram. Now say me what are the formal charges on the oxygen in the given atom? What are the formal charges of the oxygen atom marked? Formal charges, we know, right? We know the formal charges formula also. Oh, Ajit is saying question mark. Soram is saying question mark. Vigneshwar is saying one. Amit Dubey is saying one. Now we know, right? Formal charges formula. Formal charge is equal to number of valency electrons minus number of bond pairs minus 2 into number of lone pairs. Now this is a formula, right? This is a my dear friends, from the reference textbook. Actually I don't have a time, so that's the reason from the reference textbooks I was extracted these questions. Okay, now the number of valency electrons minus number of bond pair minus 2 into number of lone pairs, right? Clear? Now the formal charge on the oxygen 1, oxygen valency 6, number of bond pairs are 2 and number of lone pairs are 2 into 2. Clear? It will become 0. Now if you cross check for the second one, valency electrons are 6, bond pairs are 3, 2 into 1, then it will be the 5 and the formal charge 1, and here the formal charge is -1. My dear friends, I hope you know this formal charge. Actually I was explained very clearly this one, but I will give you one formal charge and you have to say me the answer for this one. What is the formal charge? What is the formal charge on carbon? What is the formal charge on oxygen? Say me. What is the formal charge on carbon and what is the formal charge on oxygen? What is the formal charge on the carbon and what is the formal charge on the oxygen? What is the formal charge on the both the options? Formal charge on the what is the formal charge on the carbon and what is the formal charge on the oxygen? Oxygen is -1. My dear friend, once you cross check, no, Here one lone pair will be there and here the one lone pair will be there. Now the carbon contain valency 4, bond pair 3 and 2 into 1 lone pair. So total 5. 4 minus 5 will give you the minus 1. Now oxygen valency 6, bond pair 3, number of lone pair 1. So 6 minus 5 will give you the plus 1. This is plus 1. No, carbon is minus 1, oxygen is plus 1. Okay, still if you are getting a confusion, I will give you the another molecule. Now you see, what is the formal charge on this compound? What is the formal charge on this compound? My dear friend, the lone pair of electrons, they will not give you, you have to be considered. Okay, lone pair of electrons, they will not give you, you have to consider. What is the formal charge on this compound? What is the formal charge on this compound? What is the formal charge on this compound? Formal charge on oxygen number 1 and formal charge on nitrogen and formal charge on oxygen number 2. Now say me. Now what are the formal charges on the oxygen number 1? What are the formal charges on the nitrogen and what are the formal charges on oxygen number 2? First one 0. Okay. Right. Next. Next one. Okay, okay. Next one. Next one. First one is 0. Okay. Next one. 0 minus 1 0. No. 0 plus 1 0. Yes, good. Now this oxygen contains 6 and bond pairs 2 and the number of lone pairs are 2 into 2. Total it will become 6. It will become 0. Nitrogen valency is 5. Bond pairs are 4 and the number of lone pairs are 0. So 5 minus 4 it is plus 1. Now this oxygen also same 6 minus 2 2 into 2 it will become 0. So 0. 0 0 1 0 0 1 0 not minus 1 0 1 0 my dear friend 0 1 0 there is no any lone pair of electrons on the nitrogen. There is no any lone pair of electrons on the nitrogen. My dear friends, you have to be very careful. There is no any lone pair of electrons on the nitrogen. Is it clear? I hope it is clear for you. Oh. Which of the following contain both ionic and covalent bond? Which of the following contain both ionic and the covalent bond? He is asking in which of the following contain both ionic as well as a covalent bond? In which of the following contain both ionic and the covalent bond? In which of the following contain both ionic and covalent bond? In which of the following contain both ionic as well as covalent bond? My dear friends, you cross check the each and every option and try to see me the answer. Is asking both ionic as well as covalent bond. Both is asking. Now answer is all of this. Answer is all of this. Now we know, right? NaOH will be dissociated into the Na plus and OH minus. Now the bond between the oxygen and the hydrogen, here this bond is covalent. Now I said you one trick. What is the trick I said? Delta En is less than 1.7. The bond between them, it is a covalent. Right? Now it is, most of the cases it is useful. Most of the cases. But it is not applicable for all the molecules. But it is not applicable for all molecules. Right? Now you see, oxygen electronegativity is 3.5, hydrogen it is 2.1. Then how much you will get? It will get approx, you will get it as a 1.4, right? 1.4. 1.4 is less than 1.7, so bond between them it is a covalent. Now if you consider KCN, K plus and Cn minus. Carbon is 2.5, nitrogen is 3. Difference is 0.5. 0.5 is less than 1.7, so bond between them it is a covalent. Now Na2SO4, it will be dissociated as a 2Na plus SO4 minus 2. So, okay, my dear Prashant, okay. Now be focused to the class. Now the SO4 minus 2. Now SO4 minus 2 will be in this manner. Right? SO4 minus 2 will be in this manner. Now the sulfur electronegativity is 2.5 and oxygen electronegativity is 3.5. Oxygen electronegativity is 3.5. Now both the between, now electronegativity we got it as a 1. Now the difference in electronegativity, if it is less than what? Less than 1.7, the bond between them it is covalent. So in all the cases, ionic bonds as well as the covalent bonds between them. I hope it is clear. I hope it is clear for everyone. I hope it is clear for everyone. I hope it is clear for everyone. Still you are having any confusion? Is it clear? I hope it is clear. Should I move to the next question? Should I move to the next question? Right. Lattice energy is asking. Lattice energy order. Now lattice energy order. Now lattice energy order. Now in which case lattice energy order, lattice energy high, in which case the lattice energy is high. Now in which case the lattice energy is high. Lattice energy high in which case is asking. Answer is 2. Answer no. We know, right? Lattice energy is inversely proportional to the charge of cation, charge of anion, and the radius of cation and the radius of anion. Now here the Na is same. Only you have to cross check F minus, Cl minus, Br minus, and I minus. Now higher the radius of anion, lesser will be the lattice energy. So now the higher the lattice energy, higher is the stable. So the option number 1 is correct. Option number 1. Right. Good. Now the incorrect statement, which of the following statement is incorrect? Which of the following statement is incorrect? Which of the following statement is incorrect? No, it is inversely. Radius of the anion is inversely. Now, which of the following statement is incorrect? Greatest the lattice enthalpy, more the stability of ionic compound. lattice enthalpy is greater for small and highly charged ions containing compound. Now lattice enthalpy affect the solubility of the any compound. Greater the lattice enthalpy, lesser is the stability of the compound. Greater the lattice energy increases, stability of the compound increases. Stability of the compound increases. So option number 4 is incorrect. More the lattice energy, more is the stability of the compound. More is the stability of the compound. You have to be very clear. You have to be very clear with this compound. Clear? Now, higher the lattice energy, higher is the stability. Higher the lattice energy, higher is the stability. Right. Which of the following molecule is T-shape? 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 Answer 4. T-shape, my dear friend, T-shape. Is asking T-shape. T-shape is asking. Which of the following molecule is T-shape? My dear friends, once you cross-check the options carefully and try to give me the answer. T-shape, my dear friends, this is sp3d with 3 lone pair. This is linear. This is linear shape. SF4 is a seesaw or distorted tetrahedral. Distorted tetrahedral. XeF4 is a sp3d2 with 2 lone pair and it is a square planar. It is a square planar. Now ClF3 is having the sp3d with 2 lone pair is having the T shape. So my dear friends, so the option number 2 is correct. Option number 2 is correct. Right. Now read the question carefully and try to give me the answer. Read the question carefully and try to give me the answer. What is the answer? What is the answer? Two statements are given. Both the statement 1 and statement 2 are correct. What is asking, Nana? In hydrogen atom, the energy of the 4s and 4p orbits is same. In the helium atom, the energy of the 4s and the 4p orbital is same. Answer is B. Oh, the answer is C. Why you are getting confusion? Answer is C. Now, in the hydrogen-like atoms, 1s orbital less than 2s is equal to 2p. Next 3s is equal to 3p is equal to 3d. Next 4s is equal to 4p equal to 4, 4d equal to 4f, right? For the hydrogen-like atoms. Now, for the helium is nothing but other than hydrogen-like atom. Other than hydrogen-like atom, energy order will be followed by n plus L value. N plus L value means 1s greater than 2s greater than 2p greater than 3s greater than 3p greater than Here the 4s greater than what? 3d greater than 4p, right? Now he is asking the 4p and the in the helium like atom the energy of 4s and the 4p is same. No, 4s and the 4p is not same. So statement 1 is correct and the statement 2 is not correct. So option number C is the answer. You have to be very careful, my dear friends. This type of the questions if they are given, you have to be very careful. Next, the formula used to know the radial nodes, angular nodes and total nodes for the given orbital is. What is the answer? What is the answer for it? What is the answer for it? Answer is C. Yes. Now, radial nodes is equal to n minus L minus 1. Now, total nodes is equal to n minus L, sorry, n minus 1. Now, angular node is equal to L. So, the option number C is correct. Option number C is correct. Now, the wavelength of the electron is 10 nanometer. What is the momentum? He is asking momentum is asking momentum. What is the momentum is asking? What is the answer for this one? Wavelength of the electron is 10 nanometer. What is its momentum? What is its momentum? What is its momentum? Answer is C. What is the answer, my dear friends? Kanita. Answer is C. Good, good, good. Yes. Now the wavelength formula we know, right? Wavelength is equal to h by mv. Now momentum is equal to m into v. So the h is equal to h by p. Is asking the momentum. Now take the p to the left hand side. H is 6.6 into 10 to the power minus 34. And momentum he has given now 10 nanometer, right? Lambda. Now nanometer 10 into 10 to the power minus 9 meter. Then it will become 10 to the power 8, 10 to the power 8 meter. Wavelength will become 10 to the power 8. If you take it to the numerator, it will become 10 to the power minus 26. The option is C. The option is C. Answer is C. Okay. Now, next I will ask you one question. Now, my dear friends, you have to give the clear answer for it. Now, what is asking? Total energy of an electron is 0.54 electron volt in a hydrogen atom. Find out its potential energy. Option 1, 0.27 volt. Option 2, minus 0.54 electron volt. Option 4, 2.6 electron volt. Option 3. Option 4, minus 1.08 electron volt. Now say me the answer. Say me the answer for this question. What is the answer for this question? What is the answer for this question? No. No, my dear friends. No. Now potential energy is equal to minus 2 of total energy. Potential energy, no, potential energy is equal to minus 2 into total energy. This is the formula. Total energy is equal to 2 into, yes. Now, potential energy is equal to minus 2 into total energy. Then potential energy is equal to minus 2 into 0.54. That it will give you the option number 4. That it will give you the option number 4. But is asking find out the potential energy. Potential energy is asking. Potential energy is equal to minus 2 into total energy. Minus 2 into total energy. Answer is 4. Yes. Now, which of the following ionic pair second ion is smaller in size than the first one? Yes. Now, in which of the following ionic pairs second ion is smaller in size than the first ion? Second ion is smaller than the first ion. What is the answer? Oh, what is the answer? My dear friends, be fast. My dear friends, be fast. In which of the following ionic pairs second ion is smaller in size than the first one? Second ion is smaller than the first one. What is the answer? My dear friend, try to give me the answer. Answer is A. Now, O minus 2 and the Mg plus 2 are isoelectronic. Both are isoelectronic, right? In the isoelectronic, now O minus 2 is having the higher size. Now, in which of the following ionic pairs second ion is smaller than, now Mg plus 2 and Na plus. Both are isoelectronic, Na plus is having the higher size. Next to O minus 2, N minus 3. N minus 3 is having the higher size. Mg plus 2 and Na plus. Na plus is having the higher size. So only the option, yes, Udit, you have said the right. Good. Nice. Now, which of the following set of the molecules the hybridization of the central atom is different? Central atom is having the different hybridization. My dear Vishnu, now this is a evening or this is a night. I hope this is good evening. Now what is the answer for this one? Which of the following set of molecules the hybridization of central atom is different? Which of the following molecule the central atom is different? Which of the following set of the molecule the hybridization of the central atom is different? My dear Udit, I am from Hyderabad. Prasanna is saying central atom. Which of the following set of molecule the hybridization of the central atom is different? My dear friend, I am from Hyderabad. Central atom different hybridization is asking. See in the option A, H2O is sp3, NH3 is also sp3, CH4 is also sp3, right? Not the option A. of the following set of the molecule, the hybridization of the central atom is different. Central atom of hybridization should be different is asking. Central atom hybridization should be different. Central atom hybridization should be different. No, not A. Answer is not the A. Now ClF3 if you take, that is sp3d. XeF2 if you take, xenon contains 8 valency electron, 2 fluorine. Sp, this is P, this is P. Now this is D. Now PCl5 is also sp3d. So B option is also wrong. Now C option, CO2 is sp. CO carbon monoxide is also sp. BeF2 is also sp. So the option. Now next one, SF4. SF4 is a sp3d. Now sp3d2. Now this is sp3, right? So option number D is correct. Is asking different on the nitrogen. My dear friend, I will end the live by 8:40 max to max. I mean, we are having only the less questions. 8:40 or 8:45 max to max I will end. Only the less some questions. Right. The velocity of an electron with the de Broglie wavelength of 1 into 10 to the power 2 nanometer is. What is the answer? What is the answer for this one? The velocity of electron with the de Broglie wavelength of 10 to the power nanometer. Velocity of the electron with wavelength. Now indirectly is asking the velocity of the electron. What is the answer? What is the answer? Option number. Answer is 3. Answer is 3. Okay, fine. Now right. Now velocity of the electron, de Broglie wavelength, lambda is equal to h by m into v. Now v, if you take the left hand side, h into m into lambda, that it is in the 10 to the power 2 means 10 to the power 2 will become 10 to the power minus 7. 10 to the power minus 7. And v is equal to 6.6 into 10 to the power minus 34. Mass of the electron is 9.1 into 10 to the power minus 31. Right? Into, and it is at 10 to the power minus 7. Now if you solve, you will get the answer. This if you solve, you will get the answer. Okay? Now try to solve this one and send me the answer. Now next question will move. Which one of the following set of the quantum numbers is not possible for the 4p electrons? Now which of the following set of the quantum numbers are not possible for the 4p electrons? Now send me the answer. What is the answer for this question? My dear friends, who are is in the live, try to give me the answer. Answer is 3. For 4p, which of the following set of the quantum numbers is not possible is asking. Now, for the L is equal to 1 means the possible m values are -1, 0 and the +1. But here he has given the 2, so the option number 3 is wrong. Option number 3 is wrong. Yes, option number 3 is wrong. Right. The total number of electrons that are present in the s and all the p orbital and d orbital in the cesium ion. In the cesium ion, all the s orbital electrons and the p orbital electrons and the d orbital electrons in the cesium ion. Cesium ion. Cesium ion is asking. Cesium ion. What is the answer? What is the answer? What is the answer? What is the answer you got? Now, cesium ion is asking, right? Cesium is nothing but atomic number 55 and is asking ion, means cesium plus from the 55 one electron if it is removed, indirectly is asking 54, means in the xenon is asking the electrons. Xenon is asking the electron. Xenon 1s2, 2s2, 2p6, in that manner is asking. Now we can see. We know, right, in the magic number. Now 2, 10, 18, 36 and 54. Here the s electrons are 2, here the s2 and p6. Now here the s2, now s2 and p6. Now here the s2, p6, right? Total in the s we are having 1, 2, 3, 4, 5, total 10. And P we are having 1, 2, 3, 4, 24. D we are having 20. So option number 2 is correct. Option number 2 is correct. Yes. Option number 2. Done? Right. Now, which of the following pairs are isostructural? Which of the following pairs are isostructural? Which of the following pairs are isostructural? Right. I know. Good. Which of the following pairs are isostructural? Which of the following pairs are isostructural? Which of the following pairs are isostructural? Now, answer is yes. Isostructural means here it is a sp3 with 0 lone pair. This is sp3 with a 0 lone pair. Right? Answer is 2. Answer is 2. Right. Good. sp3 with a 0 lone pair. This is also sp3 with a 0 lone pair. Now here if you cross check, this is sp3 sp3 with a 1 lone pair. Now this one is sp2. sp2. Yes. Answer is 2. Good. Now this is one very important question. Now try to say me the answer. Molecular shapes of ClF3, I3 minus, XeO3 respectively are. Molecular geometries is asking. Molecular geometries. Now one is a T shape, one is a linear, and one is a pyramidal. Yes, good. Now xenon XeO3, 0, oxygen, oxygen, oxygen. This is S, this is P, this is P, and this is P. sp3 with one lone pair, pyramidal. T shape, linear. So answer is 1. Good, 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 good. Answer is 1. Right. Now isoelectronic structures. Isoelectronic structures from the following. 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 4. No, this is sp2. This is sp3 with one lone pair. Now this is sp3 with one lone pair. Now this is sp3 with one lone pair. So the answer is 4. Answer is 4. My dear friend, answer is 4. This is all are same, right? sp3 with one lone pair. This is sp3 with one lone pair. This is sp3 with one lone pair. In all the cases, sp3 with one lone pair, right? So the answer is 4. You have to be very careful. That is sp3 with one lone pair. Yes, yes. Which of the following reactions hybridization's underlying species is not changing? In which options hybridization of the underlined central atoms are not changing? Underlined central atoms hybridizations are not changing. Underlined central atoms hybridization is not changing. More 1, 2, 3, 4, 5, 6, 7, 7. Total 9 questions are there, Amma. Total. I mean, 9 questions we will complete very fastly. Only 9 questions are there. Only the 9 questions are there. What is the answer? No, he's asking in which case hybridization is not changed. Here it is a sp3, right? Ammonia. Here it is also sp3. But here it is a sp2. Here it is a sp3. Here it is a sp. Here it is a sp2. Here it is a sp3d. Here it is a sp3. So only in the option number 1 it is not changing. Now only in the option number 1 it is not changing. Ammonia hybridization is also sp3. In the NH4 plus nitrogen hybridization is also sp3. Only in the option 1 only hybridization is not changing. Very fastly, Nana. Be fastly. Now be fast so that we can finish the lecture. I mean we can finish this session. What is the answer? Now the oxide which is more acidic. More acidic oxide is asking. My dear friend, to find the more acidic oxide, just see the central atom oxidation state and give the answer. My dear friends, be fast. If you know the answer, try to say me. If you don't know, give me the question mark. The oxide that is more acidic is. The oxide that is more acidic is. No. The oxide that is more acidic is. No, no, no. Answer is 1. Here you can see nitrogen N2O5, N2O3, P4O10 and AS4O10, right? Clear? Now in all the cases, oxidation state is which one? All the cases oxidation state is +5. Here the oxidation state is +3. Here the oxidation state is +5. But in all the cases, if the oxidation states are +5, then nitrogen, phosphorus, arsenic, top to bottom size increases, electronegativity decreases. Now, higher the electronegativity on the central atom, higher is the acidic. Now, my dear friends, 1 is the answer. Okay? Only one thing you remember. Higher the electronegativity, higher is acidic when central atom with the same group, right? This point should be remembered. Next, the tendency of the element to lose an electron is called. Tendency 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 to lose an electron, we call it as a electropositive. Sodium Na plus and the Mg+2 both are having the electropositive nature. They will lose the electron very fastly. Now F minus O minus 2, they are gaining the electron, means they are having the high electronegative nature, high electronegative character. The tendency to lose the electrons are having the electropositive character, my dear friends. Try to believe. Okay. Next, which of the following has zero electronegativity? My dear friend, which of the following is having the zero electronegativity? Zero electronegativity is asking. Which of the following is having the zero electronegativity? Which of the following is having the zero electronegativity? Answer is 1. Good. This is which one? Noble gas element. Noble gas element is having the zero electronegativity. Silicon is having the 1.8 electronegativity. Nitrogen it is having the 3. Fluorine it is having the 4. So only the argon, it is a noble gas element, its electronegativity is 0. Next, electron affinity order. Electron affinity order is asking. My dear friends, electron affinity order. Now what is the correct electron affinity order? Correct electron affinity order for the boron, carbon, nitrogen and oxygen. What is the correct electron affinity order? Prasanna is saying 1. Once again you cross check. The correct order of the electron affinity of boron, carbon, nitrogen and oxygen. Electron affinity or electron gain enthalpy. Electron affinity and electron gain enthalpy. Udit is saying 4. No, the answer is 3. Electron affinity. Now we know, right? Now left to right, electron affinity increases. But beryllium electron affinity is positive, nitrogen electron affinity is positive, and the neon electron affinity is positive. Means nitrogen, due to the presence of half filled, will not take the electron. Neon, due to the presence of completely filled, it will not take the electron. Beryllium, due to the completely filled of the s electron, it will not take the electron. So oxygen will have the highest electron affinity, then after carbon, then after the boron, last is the nitrogen. So option number 3. Option number 3. Option number 3 is correct. Now, the element having the electronic configuration, the element having this electronic configuration, now it belongs to, is asking this electronic configuration element is belongs to. 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 Just you calculate, this is a 38, 48, 50, 64, 70, 72, 72 and this is 72 and 74. 74, 74. Now we know, right? 55 and 56 will comes under the S, 57 will comes under the D, and 58 to the 71 will comes under the F. Now 72 to the 72, 73, 74, 75, 76, 77, 78, 79, 80. Up to 80 will comes under the T. So the option number 3. No, option number 3. This is atomic number 74. Atomic number 74 will comes under the D block elements. Now 55, 56 S, 57 D, 58, 71 F. Now 72, 80 D. 72, 80 it is D. Right? Is it clear? No, 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 my dear friends, it is D. It is D. Here in the D we are having only 2 electrons. D we are having the 2 electrons. You can cross check. Right? Now, next one. Now the increasing order of acidic nature of the following oxides. Is asking the acidic nature of the following oxide. No, my dear friends, it is not the F block, it is D block. Acidic nature of the following. Thank you, Rohan. Thank you. Now, what is the answer for it? What is the answer for it? Yes, yes, we can see the valence shell and we can decide. But the answer is 2. Higher the atomic number, higher the oxidation state on central atom, higher the oxidation state on central atom, higher is acidic oxide. Higher is acidic oxide. So here it is a +7, here it is a +6, here it is a +5, here it is a +4. So answer is 2. Now the basic nature order is asking. Which of the following is having the highest basic nature? Basic nature means lesser oxidation number on central atom having high basic character, high basic nature. What is the answer? What is the answer? Answer is 2. No, answer is 4. Here the oxidation number is 1. Here the oxidation number is 2. Yes, yes. Here the oxidation number is 3 and here the oxidation number is 2. But among these two, it is having it is amphoteric. It is amphoteric oxide. Al2O3 is the amphoteric. No, no, no. Answer is 4. Answer is 4, my dear friends. Decreases. Answer is 4. Decreasing basic nature. Now here to here the basic nature is decreasing. But here, my dear friends, this CuO copper oxide is having less basic nature than MgO. It is having the less basic than MgO. So the answer is 4. Now say me the answer. The first ionization energy value of the element. My dear friends, I know this is a decreasing. I mean, like, but actually, this Cu. Okay. Decreasing order is asking. Right. Answer is 2. Decreasing, right? Decreasing. Here. Right. Answer is 2. Answer is 2. Okay, fine. Answer is 2. I did not cross check. This is a decreasing. I did not cross check. The answer is 2. Okay, fine. Now, what is the answer for this one? The first ionization energy values of an element 191, 570, 872, and the 956. Now, the number of valence electrons are. The answer is 3. Answer is 3. Oh, good, Udit, good. If you take the AL, that is 3s2, 3p1. 1, it requires 191, it requires 578, and 3s1 require 872, and AL neon requires 5692. 5692. Answer is 2. Good, everyone, good. Now, my dear friend, now I just want to ask you the few questions. Last few questions I want to ask you. Now I will close the session. Wavelength of third line of bracket series. Now option 1, 19667 angstrom. Option 2, 18667 angstrom. Now last question. Now 25232 angstrom. Now fourth one, 21667 angstrom. Wavelength of third line of bracket series. What is the answer? What is the answer? Answer is 2. My dear friends, I was explained you very clearly the formula. Lambda is equal to 912 angstroms by hydrogen atom, of hydrogen atom only. Now Z square 1 by N1 square minus 1 by N2 square. Now third line of the bracket is asking, right? Third line. Answer is 4. Good. Third line of the bracket. What is the third line of the bracket? No. N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4, N is equal to 5. Lyman, Balmer, Paschen, bracket, Phi-Fund, right? Now third line is asking, third line. This is the first line. N is equal to 6, second line. N is equal to 7, last line. N2 is 7 and N1 is 4. Now here it will become 4 square 16 and 7 square 7 into 7. 7 into 7 it will become how much? 7 7 49. 7 square it will become 49. If you calculate you will get approx 4. Good Richard, good. Now daily I will do, my dear friend, daily I will do this live session. Now next one. Now electron coming fifth to first orbit. First orbit. Total number of lines. Total number of lines. Total number of lines. My dear friend, total number of lines. Total number of lines. Total number of lines. Now the answer is 10. Good. That is n into n minus 1 by 2. 5 into 4 by 2, that it will give 10. Now my dear friends, among the A, among the B, among the C, among the D. Now which one absorption of the energy? Which one will absorb the energy? Absorption of energy. In which option the energy will be absorbed? 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 My dear friends, cross check the each and every option and try to say me. This is the last question, I will end. This is the last question, I will end. This is the last question, I will end. In which of the following case having the assumption of the answer is C. Good. Answer is C. Right. Because this is a negative electron gain enthalpy, delta H is negative. This will take the electron. This will also take the electron. But oxygen O, and to convert into the O minus 2, we have to give the electron. So option number C. Okay. Right. Okay, my dear friends. Now I am going to end the live session. Now see you tomorrow with the classic chemical bonding lecture number 1. We are going to see that. Then after that, followed by the other lectures. Clear? Now see you tomorrow. Good, Richard. Right. My dear friends, if anyone is having any concerns, they can ask, and the remaining they can leave. If anyone is having any concerns and if they want to ask anything, they can ask, and remaining they can leave. Okay, bye. Now 9:45. Asterisk 9:45 I will start. For the senior advance, the live session I will start for the seniors at 9:45. Richard, I said your name. Richard, I said your name. Richard, I said your name. Don't worry. Now, if anyone is having any concern, they can ask. Samata. Yes. Now, Richard, what you have asked? What you have asked? Bye. Thank you, my dear Asterisk. Samata, what is the question? Which question I was to explain? Last one. Now, indirectly is asking negative electron gain enthalpy. Now, fluorine will take the electron. F is converted into F minus means electron gain enthalpy delta H is negative. Energy released. Cl as converted into Cl minus delta H is negative. Energy taken. Now, O is converted to O minus 2. Means first O will be converted into O minus. Here the delta H is negative. But O minus is converting into O minus is converting into O minus 2 is, that is nothing but delta H is positive. This is adsorption of energy. This is adsorption of energy. Right? This is adsorption of energy. And the last one, hydrogen is taking the electron. Energy will be released. That's it. Okay? Still anyone? They are having any doubts? Still anyone? Asterisk. Okay. Thank you for your compliment. Should I end the live? Anyone are having any concern? Should I end the live? Should I end the live? Okay, Samata, good. Okay. Richard, whatever the question you are asking, my dear friend, I don't know. Something you are asking, I don't know. Okay, anyone having any concern? Should I end the live? Should I end the live? Okay, fine. Bye. Right. My dear friend, I don't know what is a JEE means. Richard, something you are asking, I don't know. See you tomorrow. My dear friends, see you tomorrow. Bye. How to know the molecular geometry? You have to remember, na. Molecular geometry, you have to remember. There is no any trick and shortcut for that one. You have to remember molecular geometry of the molecules. You have to remember. Okay. Okay. Right. Okay.